Rico Minten, an intro to Ali in web components.
So I'm Rico. I've been at Fed for about 5 years, currently working at Deloitte Digital, where we help our clients build mostly digital products, websites, and portals. So for the past few months, we've started building our own component library. Our previous one is quite old, it's not really up to date to the latest technology. So what we've decided is to start up building a component library as web components. One of the main reasons we started doing this is as web components are a browser native feature, we're able to easily ship these with any of the CMSs that we use, or we're able to implement these in any of the modern frameworks like React Vue, without having to rewrite this custom functionality every single time. Which just helps us a lot and allows us to only write once and test properly and ship properly accessibility. During this presentation, I want to share the learnings we've had so far into making our web components fully accessible. At Deloitte, we strive to make everything AA accessible by default. And during the presentation, I will run through some of the key web component concepts to give an understanding of how they work, and some of the examples of the elements that you need to be aware of when trying to make accessible web components. So, main question, how do you make an accessible web component? And the answer is really quite simple. It's like anything else on the web. So like we've just seen from Ben, is you just write semantic HTML, use the proper tags, and just anything you would do normally for your normal websites, you do the same thing for web component. The same biblical rules apply within this context. So this is actually something that surprised me when I started, is that web components were actually introduced in 2011. Which, for context, is when IE9 was released. So for all the front-end developers, scary thoughts about supporting that browser. However, web components have only had a recent uptake, sort of the last year and a half, where people have really started looking into it as a serious solution for their development. And one of the main drivers for this is Google, whose Chrome browser is really one of the key supporters for web components. And with that, they've also developed Polymer, which came out in 2013, same time as React. And more recently, Lit Element to really support the web component development community. However, as such, the spec for web components, and specifically Shadowroot, is still very much in motion. There's a lot of elements for web components that are really only available in Google, and as such, you have to be aware of what you want to use and how you want to build your components. But then the key concept about web components is that it encapsulates functionality in the Shadow DOM. So similar how an iframe would allow you to encapsulate a different document tree, a web component allows you to encapsulate a separate part, a new part of just your regular document elements in the Shadow DOM. So the Shadow DOM has a hidden tree as part of your regular document tree. It's scoped to the shadow root, and that's the root node. So in this image on the left, you see what you would normally see when you're looking at your inspector. You see your regular document, all the nodes sitting underneath, and at one point you would see your custom element, and that's kind of where it stops if you haven't set your Chrome inspector settings to show the shadow root. When you have seen it, when you have set that to be visible, what you see is a specific tag under which the shadow root will become visible. However, that doesn't mean that web components don't allow children, because they do. So web components allow children through the slot mechanic, where what you see on the left is what you would see normally in your tree, is that you have your document, your custom element. I use custom element and web components quite interchangeably. They mean the same thing. And then in your component itself, that you've developed, you've provided specific slots where these children will slide in. And what the browser then creates out of this is the composed tree where, even though it will look like the left top, the children sitting directly under the shadow host, it will actually compose it and place them in the right spots that you've defined in your component. Another big element of web components is that you can infinitely nest them. So you can have a web component in your web component in your web component. Unlike the document tree, where there's really only one of them, you can put as many of them as you want underneath and go nuts if you want to. Advise not to, but you can. So web components in action. One of the most recent wins for web components was the announcement that Apple is going to start shipping web components in their new Apple Music web platform. But as such, web components are already very much in action right now. And for me, one of the best way of explaining what a web component is by explaining or is showing what the native browser input date does. Conceptually, this is very much what a web component is. So the input date is really exposed in your DOM as just a single line, but then when you start interact with it, it has all this rich interaction. It has the pop-up for the calendar that you can navigate through and then select your input. So this is very much conceptually what a web component is. And even inspecting the input date, it actually shows a shadow host with specific elements to format that date format as seen. YouTube has been doing web components quite a while through the Polymer framework. So inspecting your YouTube, YouTube in the browser, you see that there's all these custom YTD and YT HTML elements that pretty much define the whole structure of YouTube. And also, a personal favorite, frequently revisited website is the MDM web docs that render some of the examples also as in a web component as in the element that they've defined as shadow output. So what web components allow you to do is create any HTML tag, put it in your browser, and then have this HTML tag be whatever you want it to be. However, as these custom elements are native to your browser, by default, your browser doesn't really know what to do with it. So what happens is that the JavaScript that you write your web component in, it tells the browser that this HTML element actually has some meaning, and that it needs to do something specific with it, which is what you've defined in your code. And what happens then is that your browser then connects the dots, it sees the custom HTML tag, and then attaches the shadow root to that tag, allowing you to have the functionality that you want it to be sitting there under one single element. One too far. That said, so far so good, but there are some catches that you need to be aware of. So when we started developing our component library, we really started noticing issues come up when we started composing and nesting multiple elements. When we really started creating complexity and interactions between multiple elements, that's where quirks started coming up that we weren't expecting initially. The first one that we really found, and this was really a major one that also took quite a while for us to really find out how to resolve it, was focus management. And what it comes down to is that if you write a single component, so for example, the one we started with is an accordion. In a single accordion item, we have two children. One is the title for the button, and one is the content area for effectively what you want to show and hide. So this component works exactly as expected. There's a button, the slots are placed in the right locations. You can click on the button, you can open, close, you can tap to it, enter. It all works as expected because your browser just sees a button and acts accordingly. However, what we found is that when we started grouping these multiple accordions within a parent accordion element, and we started implementing the keyboard interactions that is specified for the accordion element, this is where things started breaking down. So the normal tabbing worked as expected. Basically, as you've seen before, the compose tree, that's really what your browser sees, so you can just go forward, backwards without any weird behavior. But then the event listeners for the keyboard interactions, they really did nothing. So trying to send the focus to the next accordion item, the focus kind of disappeared, and it didn't really tell us what was happening. So then, what was happening and what we started finding out is that looking at your components, your browser sees your custom element really just as a div. Semantically, it is a div. And as such, your web component doesn't really do anything, like sending focus to a div, like we've seen before, really kind of just disappears, which is because all your custom functionality is hidden in your shadow root. And the shadow root is effectively invisible to your main document. So sending focus to it, it just went nowhere. I mean, it didn't really go nowhere, but it didn't go to a visible spot or anything that any user would have any use for. Similarly, if you start looking at if your focus is on a button and you want to understand where your focus is on from a user perspective, if your focus is on an element in the shadow root, and you do document.activeElement, the only thing your browser will tell you is that custom element. So the main shadow host, that's what it will start feeding back to you. So once your focus is in a custom element, you really have no idea where it's actually at. And that's kind of, depending on how you write your components, can be a problem or cannot be. However, sending focus to your custom element can be resolved. Weirdly, it's not really documented, but what you do is in your web component, you start overriding your focus handler. So what happens is that effectively, normally your browser has a document element.focus. With your web component, you override the native element.focus, and you start doing what you want it to do. So in our case, what we wanted to do is we wanted to send the focus to the button element that allows you to open or close your accordion item. And the way you can access any of your elements in your shadow root is by literally doing this shadow root.create selector. Technically, the element.shadow root is available on your main document, depending on how you've written your custom element. That said, I wouldn't assume that everyone knows exactly what your elements are, so the best way is to start using delegation within your component itself rather than assuming that your users do this from their perspective. But similarly, like the unblur, if you want something specific to happen, you can override the native unblur as well in your component. So the next big item that we ran into is the flash of unstyled content. With web components, given that they're JavaScript and that your custom element is really considered a div, before it's executed parse rendered, your HTML, your browser will just render any child element with the native styles that it gets before it does anything. So for our accordion component, it really just shows like the image. You have your, in our case, just a span that is supposed to be the title for the button, and then a bunch of content. And we have an icon there as well. So it's really kind of confusing. Doesn't really tell anything. And then once the JavaScript kicks in, it re-renders the page. It puts everything in the right spot. It builds the accessibility tree correctly as well, and really changes the way your page looks and the way your page behaves. So depending on how, so always assuming the worst case that users have slow connections, not the fastest, best browsers, or just browsers overloaded, this can be quite problematic. And this can really cause issues with your whole page shifting up and down, especially considering accordions, like they're generally on an FAQ page that have a lot of content. You can look at a very long page, and then all of a sudden it can condense and completely change the way it looks. One of the solutions I'm not saying it's the best one, but one of the solutions that you have at your disposal is using the CSS pseudo selectors not undefined, effectively hiding like any custom element that you have and any child that sits underneath it. Again, I'm not saying it's the best solution because you still have at one point all of a sudden your custom element does show up, still throwing your page off, and if users started interacting with them, it still throws them off where they were and what they're looking at. But to the same extent, because you know that a specific element is not defined, you can start potentially designing placeholder boxes or kind of placeholder content for them. Or one of the solutions that a lot of the modern frameworks start using is starting server-side rendering. There's a catch here that server-side rendering for web components is a bit of a quirk, given that web components are really a core browser functionality. So it's a bit of an anti-pattern in the sense that you're trying to send something to the browser that is specifically targeted as a browser functionality. As such, it's also still a work in progress. There's a few tools that have started trying to solve this issue that have gotten some success. And the success specifically is around the testing. So also testing with custom components is tricky, given that you do need a headless browser to kind of run and see what happens in your shadow root. But as such, what happens is that your browser, so if you do server-side rendering, your server effectively creates the shadow root. It pulls it then out, creates your DOM structure as it would be with the shadow root, ships that to the browser, and then once your browser kicks in, that's when it rehydrates, removes those elements, and then attaches the shadow DOM to it. Not a great solution, but possibly better than your whole page flipping around. So the next item we looked at is CSS toggles. A common pattern, or not uncommon pattern on website, is to have accessibility toggles or dark mode toggles to enhance the experience of users, either visually or mostly visually, to allow them to customize the website to better suit their needs. Funnily enough, generally these toggles are really hard to find on websites, so kind of defeating the purpose of what they're trying to achieve. But with web components, and I kind of like this, every web component is effectively MC Hammer singing "Can't Touch This." Global CSS can't access the shadow root. So generally these toggles set some global class or something that allows any element to override, to set new styles for any element that you have on your page. However, if you ship your web component, if you ship anything as a web component, you can't set a new global class, or you can't set global CSS to update some of your buttons. This will be problematic if you have mixed patterns where some things are web components and some things aren't. For example, you have regular buttons and you have buttons in your web components. Your regular buttons will update with this pattern, your web components won't. Best solution for this is using CSS variables. So CSS variables are the only part of the CSS spec that is capable of crossing the shadow boundary and can be accessed both from inside your web component as globally. The interesting thing with even CSS variables is if you start nesting, your parent component can set variables that your child component will pick up. So cascading still applies, with the exception that any CSS set by a component, by your web component itself, is considered the user agent style sheet. So as soon as you set a global variable, it will automatically override anything that your component will try to pass down. But they still provide a great solution to overcome this problem, with potentially the downside that you have a lot of variables on your page to fully control things in your components. And the other options, and this is the one I'm personally very excited by. Also, it's a running joke now that I want native dark mode in the current project I'm on. Is starting using and natively embedding the new media queries that are coming up. that allow just natively, where the browser natively picks up what a user preference is, and you can write your components to fully user spec and not having to give them toggles. And not having to give them toggles to manually set this. So it's once and done. So the first and the third one, the prefers color scheme and prefers reduced motions, are available in Chrome and Firefox, I believe. The prefers contrast, prefers reduced transparency, not so much yet, but hopefully will come soon, so that toggles can preferably be a thing of the past. And the last thing that we came across that you need to be aware of is element properties. So by default, coming back to the Shadow DOM, is that nothing leaks. Everything that's inside the Shadow DOM is part of that tree and is invisible to the native document tree. So writing any ID, if you do in your web component, if you go to your native console and you do document.querySelector trying to find that ID, it comes up with nothing, which from a web component perspective is actually really good, because it means you can easily use IDs without the fear of them clashing. So common patterns, just using areas, area label by, just specifically pointing at an ID. Within your web component, you can do this safely without you having to fear that when this component is printed multiple times on a page, it starts pointing at different elements and the relationship gets lost. Common pattern for an input. We haven't built it yet, but just to show, this is kind of what it would show like, what it would show us. Is that your label will just point at the input. And if you print this input component multiple times, the label will always be associated to that same input field. However, the name property, kind of going against it, of an input is not scoped to the shadow boundary, but it's still scoped to the nearest form, which in one way is really kind of an anti-pattern, where it breaks the shadow boundary and doesn't provide that encapsulated functionality. But then when you think about it and you want to create a form and you want to find out what all the input fields are underneath, it's actually quite useful that it's still very much available within the form element. And as such, it means you can write a component form and component input fields doing specific things and having specific logic without you having to traverse, without you having to jump through hoops in order to find out what actually the values are within your inputs. As such, so I think personally web components are a great way of really writing, with encapsulated functionality, I think it's a great way of providing an easy way for consumers to use accessible features that you've written once without them having to understand specific DOM structures and having to implement that in the same way. It's use this tag and you're ready to go. And that's it.